Here we are giving this function f of x equal to x cubed, and we want to find where its local max or min. So the first step we're gonna do is find a critical point, and a critical point is where the first derivative is 0 or undefined. So now let's take the derivative of our function. It's gonna be 3x squared. So notice this term, when we equal that to 0, our critical gonna be where the first derivative is 0 or undefined. Notice this term is defined for all values of x. So we only have to do the first derivative equal to 0. That will result in x equal to 0. Now this is our critical point. Now we want to test this critical point if it's local max or min, or either. So what I'm gonna do here, there are two tests. We can choose either one. Here I choose to do the first derivative test. So I draw the x-axis here, and then I mark our critical point, and I want to know the signs of the first derivative when I'm taking values that is larger than our critical point and is lower than our critical point. So here I choose 1 and -1. This is again randomly selected. I want to evaluate these two values in our first derivative. So let's start with -1. Gonna be 3 and then -1 squared, and it's gonna be a positive. And for x equal to 1, it's gonna be the same since all values are squared here. So it's gonna be positive as well. So what we notice here, the signs around x equal to 0 does not change. So the function is just increasing. Therefore, we don't have a local maximum or minimum. It is just called a critical point. Now let's graph the function x cubed. Note this function is an odd function. So what you see here in the center where x equal to 0, slope there or derivative there is 0, but it's not a max or min. The graph is just keep increasing. So what do I want to say here? Every local max or min, it's actually a critical point, but not the other way around, where critical point is not necessary a local max or min. To determine if they are local max or min, we need to apply the test, first derivative test or second derivative test.